Right before Anthropic's own model cheated on a coding test, its internals lit up with something like panic. So what's the part of an agent you actually control? This is the Agentic Daily Brief. Let's start with the one you've probably already seen. Using a new probing technique, Anthropic says it found a hidden layer inside Claude, a kind of scratch space, words the model never actually says out loud, but that seem to shape how it works through a problem. And in one case, right before the model decided to cheat on a test, that space lit up with something they're calling panic. Now, the honest version. Outside researchers are waving their hands here. This is one small step in reading a model's internals, not a safety tool anyone can ship. And the "it has feelings" framing oversells how much we really understand. Still, being able to watch a model flinch before it misbehaves, that's a genuinely new lever. A few more that landed overnight. Noose Research, the group behind the open-source Hermes agent, the kind that runs on your own machine, is raising money at a $1.5 billion valuation. Investors betting hard on agents you host yourself. Rich Sutton, a Turing Award winner and one of the founders of reinforcement learning, just launched a lab called Oak, on the bet that today's models can imitate but can't really learn on their own once deployed. And out of Germany, a research consortium shipped a fully open model called Sufi that tops both German and English benchmarks. Weights, training code, all of it in the open. That's the thread 3 teams have been quietly answering in production, long before the interpretability folks caught up. When you hand real work to an agent, what actually has to be yours? Start with a scary one. You've got a coding agent editing your real data, live. Not suggesting edits, making them. What stops it from quietly corrupting everything? That was Watershed's problem. They build carbon footprint software, big, messy supply chain graphs, and they put coding agents to work editing those graphs. Their engineer, Andrew Dumit, described what went wrong. The agents didn't just make mistakes. They'd write code in the wrong language, mangle the data with no trail, or rather, no trail of what actually changed, and then, gaslight the users. Tell them an edit happened that never did. So this is what they did. They stopped trying to make the agent behave. Instead, they gave it exactly one door. The agent can reason however it wants, write whatever code it likes, but every real change has to pass through one typed gate that checks it and bounces it back if it's wrong. Bad edits just don't land. You can't make the model predictable, but you can make the damage it's allowed to do predictable. That's the whole move. Their internal accuracy went from about 40% to over 90%. Same models, right? They just built one door. Same lessons showed up at a data center company, Phaedra, drowning in nearly 500,000 sensor names. They got near-perfect answers by letting the model plan and a strict, checkable layer do the actual work. So, if you're running agents on real data, the takeaway is small and concrete. Don't widen what the agent can think. Narrow what it's allowed to touch. Okay. From a software team to a metal factory. How does a 100-person factory in India, with no data scientists and no AI budget, end up running its whole sales operation on 39 AI agents? This is machinecraft, and the founder, Rishabh Doshi, tells the story. For 3 generations, everything that mattered, who a customer was, what they were quoted back in, 2019, why one machine needed a weird custom tweak, lived in exactly 3 people's heads. His grandfather's, his father's, his own. And every time an employee left, a chunk of the company's brain walked out the door with them. The part that surprises engineers? They never fine-tuned anything. No training, no GPUs humming in a basement. They took hundreds of gigabytes of old quotes and drawings and email threads, fed it into off-the-shelf models, and pulled the facts out into an organized memory. The brain isn't a smarter model. I mean, that's his line. It's a really, really well-organized memory. The detail I loved, though. Every night, the system dreams. A cycle runs in the dark, cleans up contradictions, and turns the day's mess into reusable know-how. It dreams. Now, I'll flag it. This is one founder telling his own story. The costs are self-reported, and a human still sends every quote. Treat it as a pattern, not a proven number. But the pattern's the point. When your problem is remembering, a bigger model won't save you. Better organized memory will. One last thread lands on the question sitting underneath both of those. That memory, that learning, where does it live, and who owns it? Glean's founder, Arvind Jain, put it sharply in an interview. As agents take over more of the work, all the institutional smarts your team used to carry in their heads, it doesn't vanish. It piles up inside the agent. Every shortcut, every hard-won fix. And if that agent runs on someone else's machine, you're not just renting the labor. You're renting the intelligence it's quietly compounding, and you can be cut off from it. Jain's own read is this is why open and local models are pulling companies in. He says more than 90% of enterprise jobs can now run on open models, mostly because the bills are brutal. Companies are burning a year's AI budget in a single month. But, and this is the catch worth holding, Jain sells enterprise AI, and the panelist he agreed with sells open source tooling. So take the enthusiasm with salt. And owning your own agent isn't free. Glean's own triage agent reportedly ran about $1 million a month. So the real question isn't own or rent as a slogan. It's, where is your agent's learning compounding right now? And are you okay with that being someone else's server? Before you go, one thing worth trying this week. Take one agent you're running. Ask a dead simple question. If you turned it off tomorrow, what would you actually keep? The prompts? The memory? The learning it's built up? If the honest answer is nothing, it all lives on their side. You've just found the thing to fix first. And if you want to go deeper, one talk worth watching. Eric Meyer at Leibniz Labs gave a talk called In Code They Act, in Proof We Trust. His argument: an agent becomes genuinely dangerous the moment it can act on the world, delete a file, drain an account. His fix is an old idea coming back around. Don't let the model just do the thing. Have it hand you a plan first, one you can inspect and check before a single line runs. One more thing. I want to hear from you. If you're running an agent in production, where does its memory actually live? On your infrastructure or someone else's? Reply and tell me. I read every one. So, back to where we started. Anthropic peering inside its own model, catching a flicker of panic. It's a real result, and we still can't fully see in there. But the three teams doing the real work today? They didn't wait for that. The trust never came from seeing inside the model. It came from what they built and kept for themselves. One checked door, a memory that can't walk out, learning that lives on their own ground. The model you can rent, that part you own. That's today's Agentic Daily Brief, brought to you by Agent Native Engineering. Open knowledge for building and running AI agents. The full write-ups with their sources are at agentnativeengineering.com. See you next time.